This little video sets out to illustrate a practical usage for the STM8 Discovery board. The board is coupled with an off-the-shelf RFID card reader. I will show the software required and quickly run through the editing, compiling and programming processes to arrive at the fully working project. The image shows the Discovery board on the left and the card reader on the right. Just 3 wires connect the boards, plus and minus 5 volts supplied by Discovery and 1 data output wire from the reader. The image also shows the additional components that I have added to Discovery, namely 4-way terminal block, a buzzer and a relay. This diagram gives a connection overview of the project. The power supply source is the USB connection from a PC or even a USB charging adapter. The USB 5 volts is used by both Discovery and reader. The reader is connected to PD6 of port D, and this is also the RX pin of Discovery's UART. The buzzer is connected to a PD4, which has a special alternate function as output of the controller's buzzer driver. And finally, the relay is connected to PD2 as a general purpose I/O port configured as an open drain output. From this point on, I am going to assume that the viewer is familiar with hexadecimal and the C language. The card reader outputs the data it has read from the ID tag as a series of 10 UART bytes in a packet. The value of each byte is shown here, but the only ones we are really interested in are the 5 bytes that make up the actual tag ID. Okay, let's move on to the software. I am using the free IDE from ST Microelectronics called ST Visual Develop. It requires an external C compiler, and here I am using the Cosmic C cross compiler. There are other ways of doing this, of course. And so to the code. This file here is called main.c, and it contains the entry point for the program, which is the main function. To begin with, there are a number of initialization functions before we get to the endless while loop. In the loop, the program checks to see if a full packet of 10 bytes has been received from the tag reader. If yes, then it compares the 10 received bytes with a predefined code. If there is a match, then the relay, buzzer and the timer are activated. The timer will time out after 1 second and turn off the buzzer and relay. After a bit of tidying up, the loop repeats and waits for the next packet. The program uses a UART receive interrupt to catch the 10 bytes of data from the reader, and an overflow interrupt on timer 2 to set the duration of the buzzer and relay activation. The next task is to compile and build the program. This here is the compile button, and if everything is correct, it will exit with 0 errors and 0 warnings. Then you need to rebuild the whole program. And once again, we have 0 errors, 0 warnings. So it's now in a stage where we can move on to the programmer. This is the ST Visual Programmer. We need to load the previously compiled and built code. Then a single command will program the target microcontroller on the Discovery board. This is a very quick and easy process and is over in seconds. So let's do it. Done. So here we are back again in the ST Develop program, and we're going to run the program we have just programmed into the Discovery board. So we do that by going into debug mode, and we then run the program in debug mode. So I'm going to bring the tag over to the reader. You can probably hear it. And now the program is paused. And if we come down here, we can see the bytes that have been received from the reader. 10 bytes as predicted. And this is the code that has been predefined. And if you examine them, you will see they are identical. So we have a match. Switch it off now. So, why did I bother doing this project? Well, the picture below shows the type of devices I have used before. When they work very well. But then you throw in the people factor. They lose or damage their tags and then try and gain entry by guessing codes. Escalating anger will soon end up in quite rough treatment for the poor keypad. Add in environmental factors and the lifespan of the units is not great. Other less obvious nuisances are the awkward tag pairing process and the big one for me, having to physically travel to the keypad location to add or replace tags. And so I considered a simpler strategy and I thought about other forms of entry control. Let's just think about your home or office or shop or whatever. You will likely just have a key and a lock. And that lock has just one key pattern. That means that all additional keys are clones of the original. And this is what inspired the current project. There is just one RFID pattern programmed into the device and only one original tag code will allow entry. And just like your front door key, tags can be easily cloned. Again, just like your front door lock is pre-programmed in the factory, the design presented here is pre-programmed with the entry pattern. I'll put the code on GitHub and leave a reference below. And thanks for watching.